Good day, ladies and gentlemen, and welcome to a little pre-recorded talk for a research in progress paper here at the ISSI conference. I'm quite happy that you chose to listen to our little talk, but before we dig into it, let me give you some overarching information, so to speak. My name is Milos Jovanovic, and I will be your presenter for the next 10 to 15 minutes. But of course, this kind of work is normally not done alone. And thankfully, I've had the opportunity to have two great co-authors on this, and those are Philipp Baden and Frank Fritsche. Now, the three of us are from the Fraunhofer Institute for Technological Trend Analysis, INT, and from the Department for Technological Analyses and Strategic Planning. And we're situated in Euskirchen, Germany. Well, normally when there isn't a corona pandemic going on, and all of us are in our home office in different cities. So what are we going to talk about today? It's about reference distributions of reviews in the Web of Science and the effects of a company's policy from 92 till 2010. Now, it says here 92 till 2010, but I will be saying a couple of words about the years before and after that, and that's also in the paper by itself. So, why did we do what we did? Oh, and please don't be confused about this logo over here. That's the name of the group I am in. It's a Technology Foresight and University Up, but I don't have enough time to go into more detail there. So, why did we do what we did? About reviews. At our institute, in our department, what we do is technology foresight. That's one of the biggest topics we are working on. And our researchers, when they do that, they have quantitative analysis going on, but very often they also just simply need to read things on the technologies they are supposed to do a foresight on. And in order to be able to do a foresight, what you need to understand very well is the situation of a technology in the present. And how can you do that? You read a lot about the technology, scientific articles, for example. But of course, there are a lot of scientific articles out there. That is why reviews are, for us, not just for us, for science in general, an important class of documents, because they represent a central element of scholarly communication. And why is that the case? I guess that most of you already know that, but bear with me for a second and let me repeat that. Reviews are supposed to not be original works of science, as in we add knowledge to the field, but we collect and collate information from other articles, and we present them, we order them, we classify them, and we present scientific knowledge of specific fields. And thus, because that is the case, they are a good entry point for researchers and for a general overview of a discipline. And that is the reason why these are important for our kinds of researchers who do technology foresight, but also for researchers in general. You don't need to read every article to get a better understanding of the field, but you can simply take a look at a review and get an overview of what you want to know about. So reviews are important like that. Now, the problem is, of course, if it were that easy, I would already be finished here, but I'm not. So depending on the field, there are also lots of reviews out there. So it's not like I can read all of the reviews, even though there are a lot less reviews than original articles out there. So I need to be able to identify key reviews. And one of the aspects of that is that I look at actual reviews and not at maybe mislabeled reviews, because that's something we came across in our field of work, mislabeled reviews, and that was one of the reasons why we decided to do the work that I am presenting to you today. So there are at least two kinds of mislabel options for a review. The one thing is we have an original article that should be document class-wise an article, but it's not. It's a review. It's classified as a review. That's the wrong label. That's the one side of things. And then on the other hand, You have reviews, which when you look at the paper, at the publication, is a review, but in the Web of Science, it's classified as an article. No? And so if maybe my key review is out there in my publication, in my publications, but how am I supposed to find it? Because, for example, if I filter my data and say I only want to be shown the reviews, I don't get those that are mislabeled. On the other hand, if I only look for reviews, I might get a lot of stuff that are actually not reviews. So that was one of the reasons why we wanted to take a closer look at this kind of data and these kinds of questions, because for us at our institute, that can be a problem. When I do my research and I'm looking for the best reviews to actually read and to invest my time into them. So one of the central questions was how many mislabeled reviews are out there? And a little spoiler for that, we got a first approximation for the first kind of mislabel, and for the other we will have to do some more research. So the question about how many articles are out there that are mislabeled as reviews, we got an idea there. The other one, not yet, but we're on it. So let's see, what did we do? So we took, and that's the great thing at our institute, what we have is we have the Web of Science data. So, you know, you're able to buy that, and we have that at our institute. And because of that, we have some more possibilities to work with the data than is just possible with the online version. So we took all of the reviews in the Web of Science at the end of last year. Those were 1.8 million documents. And then looking at the data, we saw that, well, there's some strange phenomena going on there. And so we deleted some. What did we delete? There were some reviews with 0 references. So that's a bit of a strange review if you have a review that has no references. There are a number of reasons why that is there, some of them being indexation errors. So if you looked at the actual PDFs of these reviews, they had references, but those were not indexed. But it's not like those were a lot, like there were thousands of them, but with 1.8 million documents, it's not a problem if you have a couple of these. So we deleted them. And then we deleted reviews with more than 500 references because those weren't too much. And we wanted to cut the tail because the tail is very long on that side of things. So after we had deleted these, well, pretty obvious reviews, which are not of great interest to what we are looking for, we still had 98% of publications in the Web of Science that had the class document type reviews. And then we took a look at them. And as you can see here on the right, what we did was here we counted the number of reviews, how many have a certain number of reviews. And here at 0, you don't see any because we deleted them, of course. And here to the right, we cut off because more than 500 we cut off. This here is 300. As I told you, the tail is pretty long. And then we just took a look at the distribution. How does it look like? And what you can already see here, but let me make it a bit more clear on the next page for you, is we've got this big bump at 100, right there, where the arrow is. And well, what happened here? Well, why is that? That doesn't look like a natural, so to speak, distribution. It should rather look like this, but it doesn't. There is something's going on there, and maybe here as well. So what we found out, literature-wise, we found it in the data, and we also reached out to the company that does the Web of Science, and that's Clarivet Analytics. And they had a company policy running from 1992 to 2010 that said if a publication has more than 100 references, then it's a review, and then it's labeled as such. So there we had our explanation. This is the result of company policy. However, looking at the distribution again, we asked ourselves, is this amount of publications, are these maybe mislabeled reviews? So is this the answer to one of our questions? And if so, can we maybe find out how we can get rid of those? Because we want key reviews. We want the right reviews, and they here probably are not the ones we are looking for. Maybe. So what we did was we checked the categories. So we drilled deeper into the data, because what you see here is all of the reviews, and not just the ones from 92 to 2010, but the ones before and after that as well. Our subscription goes back to 1970. So what happened here? So we took a look into the data, and we saw in the categories, the so-called Web of Science categories, which are, well, more or less different kinds of scientific disciplines. And we saw that 3 groups of categories emerged, 3 classes of reference distributions. And we gave them names because that makes them easier to understand. And what you see here is the data for economics from 1970 to 2009, and social sciences. And you can see that here you don't just have 1 bump, but 2, here and here. And this is a class that seems to include all social sciences and humanities. That is why we call this the camel group, because we had these 2 bumps here. The second group that emerged was this one here. That seemed to be like a mixed group. So you had natural sciences, engineering in their, life sciences, even though life sciences you will see in the 3rd category as well. So here you had astronomy, evolutionary biology, and you have this big bump again, but here, and it's not this, this distribution that you saw before. This group we call the shark fins because of obvious reasons. And then there was a 3rd group that didn't look like an animal, but like a, well, a distribution, like a standard distribution with that's skewed. So there's a big build up here, and then it goes down. Same here, but the build up happens a little later. So here you don't see this big bump at 100, even though it's there. And the same is true here, even though it's there. And these are mostly life sciences that you can see here. So that was an interesting finding, and that's the reason why we wanted to share it with you in this talk. So there seemed to be a difference category-wise between these different distributions. Now, let me come to my last slide, discussion and conclusion. Now, obviously, a number of mislabeled reviews for the policy period 92 till 2010 can be found. However, what we also found is that after 2010, so we just looked at the data after 2010 as well, you still have this bump. So again, what happened here? What's that? And, well, as I've said here, the bump can be observed in later periods as well. And this, for us, has implications for identification of key reviews. And obviously, more research is needed on these reviews, is what we are doing. So I would like to encourage you to take a look at our paper and drop us an email maybe and comment on that. And if you have any questions, feel free to contact me or my colleagues. I'm very happy to take them. And that's it already for our short talk about review, reference distributions of reviews in the Web of Science. Thank you very much for giving us your time. I hope this was of interest to you, and have a great conference. Bye-bye.